go. All right, now we are recording. Okay, so let's try to finish up. We left off with plane. So what do you do? Point, line, and plane. And we did all those definitions, right? Gave you definitions for point, line, and plane. What's that? Did I give definitions? Right. They're undefined. Really, they weren't definitions. Okay, they were just descriptions of the words. Okay, it really technically wasn't a definition. I really don't know what the big deal is about it being undefined or defined, but they say they're undefined terms. What did I say one of your first questions on the quiz is going to be?
Name the three undefined.
Right, list all the three undefined terms. So somebody list them for me. Go ahead. Oh, you need to sit outside for a minute to settle down? No? Well, calm down. Okay, name them. Point, line, and plane. Okay, pretty easy, right? Point, line, and plane. All right, so now what we're going to do, because we talked about all three of those, now we actually are going to have some definitions. Okay, now we are, what in the world is that thing up at the top there? Don't know. How do I get rid of that? Oh, well, I'll just keep it up there. It's not bothering me. It is bothering me, but it's not in the way, at least. All right, let's do this. We're going to write down some words and some definitions. And then we might draw a few lines and talk about those. But this is really probably, to me, the least interesting part of geometry is just going through a bunch of definitions and words. But it's something we got to do because we're going to be talking about these words really all through the year. Okay, so we got to settle in on what these words mean. And then we can actually do some stuff with these words. That's what I like doing. So I'll tell you right now, geometry they basically give you a picture or you have to draw the picture. Okay, when I say a picture, not like a photograph, but like lines and planes and boxes and cubes and all this other kind of stuff. And they'll give you like the length of one side, you got to figure out the length of another side. Or they'll give you one angle, you got to figure out what the other angle is. You know, stuff like that. That's basically, when I think of geometry, that's what I think of doing. So we won't be doing that for a little bit here, but we just have to get our vocabulary nailed down, all right? So that's what we're doing today. So now we are actually doing some definitions. So these are actual definitions. The other ones were undefined. Now these are defined, all right? So we talked about what a point is. Now let's talk about a specific type of point. And the first one is collinear. All right, so collinear, I'll just shorten it, points. Okay, and basically they are points that lie in the same line. All right, so points that lie on the same line. Lie on the same line. Whoops, it's a little too many squiggles for the end, but you get the idea. All right. Pretty simple, right? So let's do an example of that. Collinear points. If they lie on the same line, I'll just slant the line just to be a little bit different. Now a line has arrows on both ends. What does that indicate? It's infinity, right? It keeps on going in both directions. So here's a point right here. Here's a point here. And let's put a point way over here. How do we label our points real quick? Somebody just tell me. Capital letters, that's right. Yeah, we'll just use A, B, and C, just make it easy for us, right? So all three of those points lie on that line. Would you agree?
Yeah.
So what would we call all three of those points? We would call them what? Collinear points, okay? Co means with, all right? And then what word do you see in here that you see here? Oops. Line, that's right. You see that word line in there? Right there. Oops, went a little too far. Anyway, you get the idea right there. See, there's line within the same line. So it basically means on the same line. So if I have 3 points that lie on the same line, so I could say A, B, and C are collinear points. What if I put a point right there and then I call it D? Are A, B, C, and D collinear? No, they're not. What about D and C? Are they collinear?
No.
Actually, they could be. Doesn't look like it is, but oops, I kind of missed it a little bit, didn't I? Let's stick that right there. Now, are D and C collinear? Yeah, they are. Okay. To tell you the truth, any 2 points would always be collinear, right? Because you could always make a line between any 2 points. Would you agree with that? So if you have 2 points, any 2 points could be collinear. But if I introduce a third one, then you got to make sure that the third one's on the same line as the other 2. Okay? So any 2 points could be collinear. Yeah.
When you had a cluster of points,
Uh-huh.
this is one, but
Well, you would say, like if I asked you if A, B, C, and D are collinear, then obviously not, because D absolutely does not lie on this line right there. I would make it so that you would understand what I'm trying to say there. Absolutely.
I think like you mean like just dots.
Like if I just said what lines, I wouldn't say just like what points are collinear. I wouldn't do that, but I would say are A and B collinear. Well, I would use three or more is what I would use, or I would say list all the points that are collinear. Okay, and you would just say A, B, and C. Basically, that's all you would do. Make sense? Okay, good. All right, so if they are not collinear, then we use the word non. I think they put a dash on here. I'm not really sure. I'm just looking at my notes, not in the book, but we'll put a dash. Non-collinear. I'm not even going to write the definition because that would mean what? Points that don't lie on the same line. Exactly right. So A, B, C, and D. What if I said A, B, C, and D? A, B, C, and D. And I asked the question, are they collinear? I'll put question mark. Are they collinear? No, they're not. But you could say that A, B, C, and D are what? Non-collinear. Good. I don't want to get bogged down on this. It's not that big of a deal. But it actually comes into play later on. Okay, so we will actually talk a little bit more about this later on. Everybody okay with that? Yeah, that's easy. I'll just keep that right there. Let's do another definition, number 2, and we call these concurrent. This is a word that you'll see every once in a while. Concurrent. Is it 2 R's? Yes, it is. E-N-T. Lines. Concurrent lines. What in the world does that mean? Well, that means lines whose intersection is a single point. Is a single point. Okay? So, if I had a line like this, and I had a line like that, let's put arrows on them since they're lines. The question is, are they concurrent lines? Well, what does the definition mean? It means they intersect. What does that mean, they intersect? They cross each other, they touch each other. Okay, however you want to say it. Cross each other. They intersect at a single point. Do both of these lines intersect at a single point? Absolutely. So here's a possible question they could ask you. We'll call that line L, and we'll call this one line M. So I could say that line L and line M intersect, and where do they intersect? Where do two lines intersect? They intersect at a single point A in this situation. Okay, so any two lines intersect at one single point. They can't intersect in two different points because think about this. Let's do this. So here's a line right there. If a line intersects in 2 points, watch. If it goes like this, in order to intersect at another point, it would have to go like something like that. It doesn't have to be exactly that, but that's the only way these two things could intersect in 2 points. Would you agree? Yeah. So, but the problem is, are they both lines? No, what did we say yesterday? The lines have to be what? They gotta be straight, yeah. This thing right here, this curvy deal, that's not straight, is it? So it's not a line. So that's the only way they could intersect in 2 points, but they can't. So two lines intersect at 1 point. You think, well, that means that all lines are concurrent then, right? Well, not really, because, oops. Did I know? No, I missed that. Let's try that again. There we go. What if I had, let's slant it again. What if I had that and I had that? Are they concurrent lines? No, because concurrent lines have to do what? They have to intersect each other, don't they? Okay? These two right here. Now, I copied and pasted them since I got this little cool computer program. I copied and pasted them so they're slanted the exact same way. So there's no way I could extend this forever and ever, and this one forever and ever, and they'll never intersect each other. Okay? So we don't call those concurrent lines. I'm getting a little ahead of myself because this is actually the next to last definition that we're going to do. But anybody know this? What do you think? They're called parallel lines. We'll get to that in just a few minutes. All right? So they would be parallel lines. Again, I just kind of jumped ahead. So these are intersecting lines. These are parallel lines. Parallel lines would never intersect each other, so they can't be concurrent to each other. Yeah, no. Like right there? Okay. All right, everybody with me on that? The parallel lines? All right. All right, I got a little example to do. You got that? Okay. So let's jump up here. Let's change colors. Tired of just the black and white. So let's draw a couple lines. Well, a few lines here. This is in the book, but it'd be good if you wrote it down. So we got 2 lines like this. We got 1 line like this. And then we got another line that kind of goes like this. Okay? Let's label them. Let's add a little splash of color here. So this is an example that kind of talks about concurrent lines and collinear points and all that kind of stuff. So this is kind of the stuff you might see on a homework or on a quiz or a test or something like that. By the way, while I'm thinking about it, the quizzes and the tests are basically, not always 100% of the time, but they're basically problems straight from the homework, okay? So I don't go out of my way to try to find like extra hard problems that you didn't do in the homework. I try to pick problems that you would have seen in the homework, okay? I might change a few things around. Instead, in the homework it might have been A, B, and C, and I might have made it like X, Y, and Z or something like that, But as far as the basic problem, it's basically from the homeworks. So that's why it's so important to do the homework. This line right here, I'll tell you what, let's do another color. This line we'll call, that's a lowercase k. This is a lower L, that line right there. This one across the top is the M, and this one is N. Remember how we can name lines with just one letter as long as it's lowercase? That's what we're doing here, okay? So, the first question says, name 3 collinear points. So, problem 1, 3 collinear points. Yes. Go ahead. So the R's, that's probably what you're going to ask, isn't it? Like that R right there, it's a point. And so what it does, it represents where they intersect each other. Is that what you're going to ask? Yeah, that was my bad. I kind of made an assumption. But that's how they're going to see it. Like this S right there, what do you think that S is indicating? It's the point where the 2 lines intersect each other, exactly. Now, I actually did put a dot here, or a point right there with a V, because you wouldn't know where the V would really be. But that's where it is. And where's the T? That's this intersection of those.
What's the V for?
The V is just a point on this line. Okay, just some random point on that line somewhere. Okay, in between these 2 points. So problem number 1 says, name 3 what did I say? Collinear points. Let's write it down. Name 3 collinear points.
TVS.
Points. Okay. What is it? T, V, and S?
Yeah.
Yeah, how do you know they're collinear?
Because the line diagonal.
Well, because they do what? What's the definition say?
They're all the same.
They're on the same line. That's right. Okay. T, V, and S. And that's how you would write your answer. You just put commas in between. You wouldn't write like a T, a V, and an S all right next to each other. Okay. You put commas in between to show the different points right there. Are there any other? What about R, T, and V? No, because they're not on the same line. Is there any other? R, S, and T? Is that what you said? R, N, T, but that's not 3 though. Because it says name 3 of them. Right? That's it, I think, isn't it?
Yeah.
Yep. There's only 3. All right, so that was easy. Number 2. Now we talked about collinear points. What was the next thing we talked about?
Concurrent.
Well, before concurrent,
Non-collinear.
non-collinear points. Okay. So name 3 non-collinear points.
SRT.
Okay, S, R, and T. Yep, S, R. Now R and T are collinear, but if you include S as part of that, then it's non-collinear. So that's right. So S, R, and T. Is that the only ones?
R.
I could put an and. I could put and or, right? So you'd be done. If they just ask you that question and you put S, R, and T, then you'd be done. Okay? Is there anything else?
RSV.
R, S, and V. I'm not going to write them all out, but R, S, and V, that would be correct. Is there any other combinations? VTR. Yep, V, T, and R. They're non-collinear. So you really have a possibility of any of those answers. Did we get them all? Did we say R, S, and V?
Yeah.
Okay. Yeah, I think that's it, isn't it? Yeah. Okay. Number 3, it says name 3 concurrent lines. I'm kind of running out of space here. Let me just stick it right here. Number 3. So name 3. I'll put name. Name 3 concurrent. What does concurrent mean? As far as lines, they all intersect in one point. Right. Name 3 concurrent lines. Okay. I'll put a little thing there. Do you see 3 lines that all intersect at one point?
Yeah.
Okay. Let's use, now they're asking for lines. Now you could call this, see this line K right here? You could call it something else. What could you call it? RT. You could call it line RT. So you could call it line K or line RT. But they put the one letter things right here just to make it a little easier for us. So let's use the one letter, okay, the lowercase letter ones, the blue ones. Is that all right?
Yeah.
Now we could have called it RT, and that would have been fine, all right? But, you know, now this one, I don't even have a point on this one. So like this, I couldn't use the letters, could I? Like the capital letters to name this line right here, because I only have one letter on that line. I couldn't call it TN. That's supposed to be an N. Looks weird. That's an N. All right, so you can't call it TN because you could either name it with 2 points, right, capital letters, or just one lowercase letter.
I was going to say that K and
Yeah, okay. Well, K doesn't... Yeah, K goes into M right here. Is that what you're saying?
Yeah, I was saying the line would be all the way down here.
This one? So line K. Yep, this whole thing would be line K. This one would be line L. This one across the top would be line M. This one right here on the bottom would be line N. So which 3 lines all intersect at one particular point? K. Is it K, L, and M? Well, K goes here, L goes here, M goes here. Where's the point where all 3 of those? Oh, N. Did you say N? Okay, my bad. I thought you said M. Right? Yeah, K, L, and M would be it. See, K comes here. So where are all 3 points? Only at one spot, right? There's only one spot on here where they all intersect. Well, 3 lines, I should say, intersect at one point. It's right there. So what lines make up that point? Well, line K. So I'll put a K, lowercase k. And then line L, which is that one right there. And then line N, not M, but N. My N is really weird looking in there. But anyway, that's what it is. Does that make sense?
Yeah.
It's pretty easy. I mean, you don't have to be good at math to be able to do this, do you? No, there's really no math involved. All right, it's just knowing the definitions, know what these words mean, and you're good to go. I'll tell you what. We only have 5 minutes left, so we still have a few definitions to go, and then I got another big picture to put on there, and we got to talk about it. So let's just stop there. I don't think I can cram that into 5 minutes. Now it's 4 minutes. So we won't have homework tonight. Don't get used to this, because most of the time, not all the time, but most of the time, I'll do a lesson in one class, and then I'll give you homework on it. But we've had all these interruptions, and it's hard to get a whole lesson done when we don't have a full class period. So, all right, everybody good with that?
Yep.
Okay, we'll finish this tomorrow.